25,000 கட்டிருப்போம் தெரியுமா? அந்த இதெல்லாம் தந்து பேங்க்ல ரூபா கட்டுச்சுல அந்த 25,000
I guess Divya has someone
I'm
speaking.
muting. Yep. That's that. All right. Okay. So I'm not going to execute anything. I'm not doing anything. I'm just going to open up this contract so we can walk through this contract. I think this font is like slightly better than what they will have in the video. I will also play the video side by side. All right.
That's some Rust experience, but these contracts we're looking at today are going to be new for me, so it's exciting.
I'm Chad, in the same position as Mike, DevX engineer. This contract is new to me. Less Rust experience even than Mike, but like some familiarity. So, Josh, who are you?
I am Josh. I am also a DevX engineer, and my Rust experience is even lower than these individuals. So I'm really looking forward to learning more.
My name's Sharif. I work on education in here. I can spell Rust confidently. Looking forward to it.
All right, let's start. Let me present my screen. Today we're gonna discuss a voting contract, and this is the contract that was used by mainnet to move from phase 1 to phase 2. So validators had to vote to enable transfers, which essentially made the network fully decentralized. Okay, so this is C-Line. I'm using it as one of the greatest tools to work on Rust. And this ID, so on the left you can see a repo for core contracts. This is open sourced on GitHub on our page. And there are a bunch of contracts, and one of them is voting. So let me first go through a quick structure of how this all works. So on Rust, you have src and lib. Lib is a main file. It's a library because we're not really compiling a binary, but we're compiling a library into WebAssembly. There is a cargo tomo. This is the way to describe dependencies. So we're saying we're gonna build a voting contract, and we use NearSDK version 2.0.0. And there's a bunch of flags that we use to tell how to compile this release build. So there are a bunch of optimizations that improves the size of the code. Then we say there's no debug info in the release, and also panic is aborting. This is important for WebAssembly. And finally, we have overflow checks equals true. This means when integer overflow happens, something like you can subscribe, or you can subtract a number. So let's say you subtract 2 from 1, and this goes to negative. And if your integer is unsigned, this will make it panic at this operation. So on C++, it usually silently rolls over. So on Rust, you can enable a flag that will make it panic on any overflow, or if you exceed the limit of the integer in either direction. So if you go beyond U32, this will also panic. And when you develop contracts for any smart contract platform, usually silent overflows are not intended behavior and can lead to abuse. So ideally, your contract will panic and you'll just handle it. So this is just for safety. Then we have other files, and we'll go there later. But first, let's start with the main contract. So this is a single file, and it is fairly simple. At the same time, it has some interesting stuff. So the way The way contracts are done at Near Protocol in Rust is we have a main structure. So in this case, we're using a structure called voting contract. Structure is similar to class in other languages. And we have a few macros here. So near bindgen is a macros from near SDK that turns the structure into something that we use for contracts. And I'll go later into details. And both deserialize and serialize are two macroses that allows this structure and all fields in it to be serialized to our binary format called Porsche and deserialize it. And this is needed to be able to store this entire contract into a state. So the way contracts work is they have some persistent state from which they can read information on every invocation of the contract. And then they have a local memory, which is only available when a contract started. So let's say, it's probably gonna be better explained later. So we have a structure, and then in Rust, you have implementation of the structure. Implementation of the structure is basically methods of the class. So one of the methods is new. This is a constructor. It doesn't take any arguments for this particular contract, and it returns self. Self is the equivalent of a voting contract. Basically, it's saying that it constructs a new instance of this class. We have a decorator macro called init. And this init allows us to initialize a state of the contract without having a previous state. The way how contracts usually deployed on Near Protocol is you deploy the code of the contract. Essentially, you deployed a class. And then you need to initialize an instance by calling a constructor. This will write a state, in our case, this particular structure, into a persistent storage of the contract. So it will be available every time you call this contract.
So I can just explain this concept because, like, for those who are not familiar with smart contracts or like blockchain, I think this might be not so. I mean, it won't be so straightforward. But basically, as he mentioned, like everything that we store on the blockchain, like think of it as like variables, but those variables will undergo some state changes, right? On chain. So when we say data on chain, when we are writing some data on chain, that means we are changing the state of a particular variable. So think of it very simply as something like, when we say a is equal to 10 and then we make a is equal to 15, right? So basically, why do we need to think about state changes? Any programming logic, right? Any business logic or any programming logic for that matter requires you to think about state change, right? Initially something is happening. If something happens, then something else happens, right? So that's basically the workflow of how programming logic works. And that's what when he always says state, think of it as some variable which is changing state, right? Now this one that he mentioned here, the init macro, is basically why we use this init notation or init macro is it will create a new state. It will initialize the state of this particular structure. So we have this structure, right? But this structure is just written in this program, right? Once we deploy this program on the blockchain still doesn't know about this structure yet, right? All of this is just like some kind of binary encoding for the machine, right? So the init, wherever we use this init macro, this new is the constructor. So if you come from any programming language background, then constructors are used to initialize that particular piece of code, right? That function, that contract or whatever. So this constructor, it's a standard name, always call it new, right? This constructor, the init macro tells the chain that this particular constructor is going to initialize this particular struct on chain. So that's how you can say that there is a, you can see that there's a check called state exists. So this will not do the initialization if a state for this particular structure already exists on chain, right? So that's what basically this init macro is.
Does it make sense so far?
Yeah, so he's asked if it makes sense so far. If there is anything that doesn't, then we should just stop and discuss. Is there anything that is like not so clear at this point? Okay, shall we move forward? Okay, cool. Okay, awesome. Okay, let's move forward then.
Okay.
So far, so good. So far, so good. There's a couple of ideas that you're talking about that are a little bit new, but I expect watching the video again would help.
Okay.
Yep.
So
don't worry, even if you're just getting started with Rust, because as you can see, all the other folks who are on the call are also almost just getting started with Rust. So if you feel like it's too overwhelming, you can always rewatch the recording. And I'm also showing the contract as well. And this is all available on the GitHub repo. So you can always go through it again, right? But just to, this is like basically just to get some context in terms of how the structure of this Rust language looks like, and how you can think of a logic and program it in Rust.
let's go through the constructor first. So when you first initialize the contract, the voting contract, it doesn't take any arguments because, well, it doesn't need to know anything because it will only rely on the current context of the blockchain. And this context comes from a module called env, which is short for environment.
Yeah, env.
From near SDK. This is where we'll need information down the line. And we'll use arguments that other contracts or users call this contract. So there's two things happening at the constructor. First, you check that the state doesn't exist. It means the contract is not yet initialized. So this macro allows for the contract to be called multiple times. So it doesn't check if the existing state already there, it allows to do this. We are working to add another macro, which is we call init once, that will allow only to initialize the contract once, and it will do this check automatically.
Okay.
So assert is similar to unit test.
Assert.
It just verifies that the given expression is true, and if it's not true, then it throws a panic, which is stops the current function call and sends this message as an error. So it's saying if the state doesn't exist, or if the state already exists, basically in reverse of this, then the contract was already initialized. And we cannot initialize this again. So if we didn't have this, then we would be able to override whatever was there with the new state. Then
Question.
yes.
Does state exist?
Oops, I thought one of you said question. Okay.
work together with init? Is that where it comes from? Like what state is it checking?
No, so state exist is actually comes from near protocol. And this is the internals, how it works. So we probably need to look at how near SDK in Rust works to better explain. So every time not a constructor is called, so let's say this is a method, it takes the argument mutable self. And by using this decorator near bindgen, it creates a specific code from this contract that does a bunch of operations before getting into the execution. And one of them is if you take mutable self or self, it first tries to deserialize the current state. The way it works is on a low-level API, we have a state key. So this is the key for which we store data of main structure. So
Okay, so I'm going to go a little bit now inside the code. So this, what they are saying, what basically he's saying is state exists will come from the environment, and environment is present in the near SDK. So basically near SDK is just like how we import different libraries in our code. Similar to that, we have near SDK. There is a near SDK for Rust that you would need to download. Now this environment variable, when we go inside, I mean the environment, it has this check called state exists. This is what we are using. What it's checking is if the storage has key. So this is the state key. Let me search for the state key here. I just saw it in Rust. Yeah. So basically, like state of the contract, right? Like he mentioned, every contract will have one struct. That is the primary way of defining what are the variables and methods in that particular contract, right? So as he mentioned, a struct is similar to your class, which will have variables and methods. Now the state of that particular contract, that is the struct that we are initializing, will be present in the state key, right? So whenever we are checking if state exists, so internally this is what it is doing. It is checking whether the storage for that particular contract, does it have the state key, right? So if it has the state key, that means state exists. If it doesn't have the state key, that means it can initialize. If the state key already exists, it will say that this contract is already initialized. So for many of your Rust contracts, when you start working with it for the first time, you may not realize that you have to call the new function for many of the contracts. Unless you don't call it, you can't call any other function because the state key doesn't exist for that particular contract. So it will not be able to do any other functionality. This is something I suffered a lot while debugging a couple of days ago. That's why.
let's say in a constructor, we constructed this state. Basically, this is a return in Rust. If the last value, you return this new structure, which we initialized the way we want it. And then this structure, by this macro getting serialized to a binary format, Borsch, and getting written into this persistent storage under a key state, and the value gonna be the current value of the structure. So next time a method is called like this, it first will read the binary part out of storage, deserialize it, and create this structure. So, and then only after this part will start getting executed. So this is part that comes from near SDK. It's basically a wrapper around. All it does, it checks if the given storage
Yeah, if it
has this
exists or
particular,
not.
if the storage has this particular key, and if it has a key, then it knows that the state already exists.
Okay. I was thinking that maybe the contract itself, the binary of the contract, was being stored in the same location in some database with the state. So that was part of my confusion. The other part is, what does init actually do?
Init.
So init allows you to, at the end of so it expects that you return a new class or a new instance, and it will write it to the storage. So this is what it does. Basically just saying that I don't expect any arguments, but you will return me a new state that I will write into the storage. So
It's indifferent as to how many arguments, to clarify, right? Like you could pass arguments. Okay.
Yes. Okay. So we can also have a default on the contract, and we don't want our contract to be initialized with a default argument without calling initialization. So we say if a default method is called, so this happens when the state doesn't exist, so it was not initialized, then this method is called default. So we don't want this to happen, so we're saying it should be initialized first. So it basically just panics with an error.
Usually isn't default called automatically when you call any other method on the interface? That's why you have to kind of override it with this panic.
So yes, nearest decay, it basically tries to first read the state from the storage, from the state key. And if it doesn't exist, then it will call default. But if it exists, then it's not going to call default.
Gotcha.
Yeah, so basically what he's trying to say is, like, if we call any other function, right, like this ping or check result or any other function, before calling this new, it will automatically call this default. So if you are familiar with what is that, switch case, in switch case, what happens is, like, you give some specific numbers, right, 0 1 2 3 or whatever, and if your input is something separate from that, it goes to a default. So think of it similar to that, but basically whenever you try to call a function without initializing this contract, it will say voting contract should be initialized before usage. That's why you need to define a default for your particular contract.
Cool. So let's go to the first method and see what we have. So let me just see the interface first of the contract. So we have a few methods, and Rust.
So he has opened some interface, which unfortunately I'm not able to find on my list of files. So this interface that he has opened just has a list of the functions. So I don't know which file. So lib.rs, I am on the same file. I don't know how. Oh wait, I think what, okay, I got it. Shucks, I feel so stupid. Okay, so what he has done is he has just done like this. Wait. So he has just like, okay, I get this. So tests, that's fine. Okay, so he's just going to look at all the functions first. Oh, I was thinking, is he opening some other new file? Okay.
Is a decorator of pub, which means visibility is public.
Yeah, so pub
And
is
if there is no
public function.
visibility, it means that it's private.
Yeah, if there is no visibility.
Near binding decorator only turns public methods into the methods that you can call on the contract, which means check result method is not exposed to the contract. It cannot be called by someone else. All the rest of these methods can be called by anyone, essentially.
And just to double
maybe-
check in Rust syntax, the pub modifier could be on the implementation. All the methods could be non-pub, but the implementation's pub. And then they would all be part of the interface.
I'm not sure about this. I think implementation doesn't have a, well, maybe.
Okay.
I'm not
I don't know.
Yeah, so if you guys got the question, even I'm not sure, we have to research. What Sheriff is asking is, if I make this pub and I don't add any keyword here, will that mean that all the functions are public in nature? But what this guy says is he doesn't know, and he also said that like maybe implementations don't have any visibility. So the implementation keyword itself won't do anything. You have to define the functions inside the implementation. So that's what he mentioned. So he said, I don't know.
Oh yeah, that's what I was just checking. I think I saw that before now.
Okay. I don't think.
But if
it's
we try to
true,
change
but
it in
I
our
don't
contract, it
wanna
doesn't
argue
work. It's showing
because
error.
I'm
I
not
had
sure
tried
about
this
this.
last time like this.
So
it's
Yeah.
not-
one more important
Yeah,
thing
so it is.
about near SDK is a difference in arguments that you pass. So if you pass argument mute state, it means the method will be allowed to modify the state. We call this type of methods regular function calls. So they can only come through a transaction. And in contrast, there's a without mute self. So the state of this structure will be immutable. It's basically a read-only state. You cannot modify it. And this type of methods can be called using view call. And they are not going to modify the state.
So just a quick difference. Basically, this is specific to near. They have two different types of calls. Like one is like called transaction call, which will affect change in the variables. Like for example, these variables, the structure will be stored on chain. If we want to change the value of any of that, we need to create a transaction call. Whereas other calls, which are just getting some value from the chain, we can use something called view call. That's what he's mentioning, specific to near. And one more thing he mentioned is that this ampersand mute, which refers to mutable, right? So ampersand mute, that means that we can mutate or we can change the data that is going to be on chain. Whereas whenever we are not using the ampersand mute, or we are not using mute anywhere in Rust, that mute keyword, that means we can't change. That is like constant, right? So that's what he's saying. Like mute are will come as transaction calls wherever we are taking mute as the parameter, and wherever we are not mentioning mute, it will be, we can call something called view calls. And one more thing in Rust that we have to remember is first argument for every function should be self, unless and until it is new, because it's init function. For all the functions, if you see, first argument is self. That means we have to send that it's like object oriented programming taken from C++, the principles. So we have to send the self whenever we call this, the first when we write the contract, the first argument should be self. So it can be either mutable or it can be non-mutable, up to us. And this ampersand, they are using something called references. So this is slightly more complex. Even we don't understand it that clearly, but there are videos and all that you can watch.
And
So that's a quick way to tell if it's a view method.
One thing.
Yeah. Shweta?
Yeah, I was saying that if we use ampersand mute, can you go to the code? Yeah. So ampersand mute self. But if you want to pass more than one variable, like after self there's is both
Here, yeah.
or something like that. So we are not using anything for that. So does ampersand mute self signifies mutability for all the arguments? Like we need to check
Yeah.
that.
So self basically, yeah, correct. So actually one thing that we missed, I think we did not notice. So what he mentioned, right? Like for example, when he was defining this constructor, no, he was saying this returns self. What is self? Self is an instance of voting contract. So basically, we are sending an instance of the voting contract. What that means is whatever is there in the voting contract, whatever variables are there in the voting contract, you can change that. That's what self here signifies.
Okay.
So that's what he mentioned from there.
And then inside the function itself, we can access those variables.
Yeah. See, you can say self
Yes,
dot.
yeah. Self dot something. Yeah.
Self dot.
We use it in Python the same way.
Yeah, exactly. So that's what he's saying. Like, and it is in Rust. This is mandatory, not just in contracts. Whenever we write Rust functions, we have to send self as the first variable. That means we have to send an instance of that particular whatever that RS code, right? Instance of that code. We have to, instance of that class or structure, whatever it is, we have to send that as the first variable. And this is not being passed. Actually, nothing will be passed from the front end. What we will pass as be only these. But while while writing the code, we have to add that as a variable.
Can you please explain again that self part?
So self part, what he says is, and you guys can rewatch the video, I will share. So what he says is, he explains during the constructor that here, if you see in the syntax, actually, public function keyword for defining functions. This is the name of the function. New means it's a constructor. So this is a constructor function which is not taking any arguments. This arrow signifies whatever comes after this arrow signifies what this function will return. So this function is returning something called self. So what he says in the video is, self is nothing but a instance of the same contract of this structure. So basically, this, you can think of this contract as this structure, because this contract is nothing but this structure and the functions associated with this structure. So when we say self here, we are referring to this an instance of this contract. So when we go to think of object-oriented programming, we create an object of that particular class, right? Like in whichever programming language. So most of Rust has been adapted from C++. So you can see a lot of object-oriented references.
One question, basically, when we go to any like object-oriented like Java or something, so we don't have, when we initialize a constructor, we don't return anything.
Yeah, correct. But here they are returning self. So why they are returning is because in near SDK, what they will do is, whenever the constructor is called, they will write that state key into storage. So this environment has that state key. So state key, they want to write this state key. So unless and until this, so that's why they have that init macro will take whatever is being written from this function and write it to the state key, thereby telling the blockchain that now the state of this particular contract is initialized. So that's why this will return, this new constructor will return this self.
So this voting contract will be initialized only once, and once it's initialized, basically we will that initiate that state key and store in the
Yes. So the storage, that state key refers to telling the blockchain that now this contract is live. Unless and until we initialize a contract, the blockchain will not have any understanding of any of these other functions. That's how they have defined in near SDK. Exactly how it works at the compiler level, I'm not sure, but that's how we have defined here. And one more catch in Rust is, we don't need to use a return variable. So if you see what is happening in this piece of code is, we assert this and then we say voting contract. That means we are creating a new object of that structure, and then we are assigning the value. That is, votes is a new hash map, total voted stake is 0, result is none, and last epoch height is 0. So if we see the struct, actually the struct will have the same variables. So this public struct has votes, total voted stake, result, and all these things. What they are doing is, they are just initializing it and they're leaving it. So this becomes by default the last. So the last statement of the function becomes the by default the return. So this is automatically getting returned. So that's why this init macro will take the return and it will write into that state key. And then onwards, we can call the other functions.
Okay, yeah. So one another question. So I see that there is something called default. Maybe like you have already explained, but there was some audio I couldn't able to go. Yeah.
So
What is this?
So there are two implementations we can have. One is, this is the main implementation, which will have all the different functions of this particular voting contract instance. Then there is a default implementation. So it's up to us actually to add this or no. But default implementation will be like, if we do not initialize any of this and try to call any other function, it will go to this default implementation and say that voting contract should be initialized before usage.
Okay, so is it like a kind of default constructor we have or something like that?
Yeah, kind of. It's, I wouldn't, you can call it constructor. I mean, but it's not like constructor, but like switch case, think of like switch case. If none of the values are matching, it will go to default. So here it is, if we define the default, then we are giving them a fallback that if nothing matches, then you print this. So even if we remove this default, right, it's not mandatory to have. If we remove this default and call any other function, we will get a message saying smart contract panicked.
Okay.
So then we can't decode why it panicked, we don't know. But if we add this panic message, we will know that, okay, it panicked because it has not been initialized. That's why it is recommended to add a default implementation like that.
Okay. And when we do the implementation of a particular struct, as we see the structure above, and we have like few variables over there. And when I go down and see the implementation, I see there are functions which we haven't defined there. So we can like add, not this one, this is a constructor, but if we go down like this ping, and we can basically define this way the functions.
Correct. So implementation, again, I don't know why they have this some wrapper kind of thing they have created in Rust, but basically implementation, this IMPL keyword is used to implement the functions of the struct. So within the implementation, whatever functions you have, those are the functions that are the functions for this particular struct. So we can have multiple structs as well. Like if we have this, right, we can have one more structure, pub struct something else, and there'll be different implementations for that struct, like implement IMPL something else like that. So when you call the constructor of that struct, then the storage of that struct will be initialized. It's like that. So yeah, but that is in normal Rust. I don't know in near SDK whether we can have more than one. I'm not very sure how it may work. But I think maybe it will get added to the, or new state key will be created. Exactly, I don't know how it will work. But in normal Rust, we can have more than one structure. And for each structure, we can create implementation, which will have functions defining, defined for that particular structure.
Okay. Yeah. Thank you. Thanks a lot for explaining.
No problem. Should I continue?
Yeah.
I feel we can only do half today, but okay, we can do the half next class.
In Rust is just, if it is mutable, you can assume it's a change method.
Right, it can be called as a change method, basically. And I think if you don't have mute self, then it will not write a state at the end. I'm not sure we enforce this as a view method only on near SDK. You may want to check this on the next call. But the important part is we should treat them as non-changeable methods. So they are not modifying the state.
Yeah, okay.
And usually they intended to be a view methods versus mute intended to be a change methods. So before we dive into any particular method, let's look into this one. It has an argument in addition to state.
Vote.
So by default, NearBungeon expects methods to be passed, or arguments to be passed as JSON. So default deserializer of arguments, JSON. So this piece expects a method to be called with something like the following. So method name vote, and argument's gonna be a JSON in format of is vote, for example, true.
So again, I have one question here.
Yeah.
So this is the
Yeah. So basically, when we initialize that particular struct, okay, and we have that implementation got initialized with the constructor, whatever value we have passed, and now when we are invoking any of this function, I see that there's something called at mute self. So this is nothing but the value which we have initialized and the
Yeah.
state whatever we have at the time of initialization.
Yeah. Same. And this one, what they are saying is very important. Actually, it is the way we have to call the functions from the front end as well. So what they are saying, that
Mhm.
this near bind gen expects all of the input to be in JSON format. So
Okay.
whenever we send, so here, right, again, I told self is not something we'll send from the front end, right? It is just
Yeah.
understood that it's, whatever was the initialized state. So here, how we should send the, whenever we call the method vote, so whenever we call it from CLI, actually we call it like this, that we'll write the name of the method, then
Mhm.
the arguments itself we have to put in JSON. So we have to send something like this. So like bool. So this is what it expects, or sorry, not bool, true.
Value, true or
Yeah,
false.
so true or false. So any input that we send, it expects it to come in JSON. So
Mhm.
I don't know if this is the case with actual Rust. I think we have to take a look. But in this SDK, that's what
arguments,
is
the raw
expected.
arguments that the method expects. And this is
So that's what,
important
yeah.
because you cannot pass arguments using positional call into a contract. But internally, within this implementation, we can call vote with positional arguments. And within unit tests, we can also use positional arguments.
You can use either or.
No, so basically, if you're within Rust, same Rust, not calling the WebAssembly binary, before near branch does magic to turn it into a contract, then you should use positional arguments. But if you calling it either from simulation tests or from like on a blockchain actually, then you are already calling a precompiled WebAssembly library binary contract, and it will expect it in JSON format. So the raw WebAssembly doesn't know any type inputs, and the parse input completely different. Probably it makes sense next time to go through expanded macro. I don't want to go on this call, but we can do basically run macro expansion on the compiler to see what's the raw code is generated for every method, and it will be easier to see what's happening behind the scenes before we actually get to execution of the body of the method.
Yeah, I have not understood this dispositional exactly, but I feel it is something like, if we had more than one argument, can we send one argument before the other? Because in JSON, I think it doesn't matter, right? The order in which you send, because it
Yeah.
will take it as a JSON and it will try to match the, like, the pair, like it will try to
Key, the
vote
key
and
value.
the value. But I don't know, he's saying something which I don't really he said you can send it positional, but after compiling it doesn't matter, or it matters. So I'm not really sure what he's trying to say, whether we can send it positional, or because what he's saying WebAssembly part is like this contract will, once we compile it, um, it will become WebAssembly. That is this near bindgen and all. It will make everything as JSON. But does that mean after compiling into WebAssembly, it will positions will get fixed, or can we still send in any position? That part I still didn't get, and I didn't get time to research also. So I will try to look into this. Because it will matter a lot when we are calling from front end. Sometimes we may by mistake switch the arguments. we send the first one first and or second one first one second. So will it make a difference? That I don't know. Exactly, I'm not sure. If anybody understood, let me also know. Yes.
Um, okay. And finally, return arguments. So this view call returns an option of wrap timestamp. So the return types after near binding contract macro expansion are also JSON. So this type is a specific custom type, which is U64. So this is coming from near SDK JSON types, and it is a structure. It's probably too much Rust. It's a structure that has a raw U64 type, but when JSON's deserialization is called on it, or serialization, it turns it into a string. The reason for this is JSON standard doesn't support all U64 types, like not full range. It only comes from, I think the limit is something like 2 in the power of 53, because JavaScript originally had this limitation on numbers. And JSON standard, the default JSON standard that comes from frontend, will not serialize large U64 numbers into a proper number. So instead, we wrap 64 integers. U64 is unsigned 64 bits integer, and U128 integer into strings. So that method will return you a JSON, something like this, which is basically a string if where the actual number is like 1,000. Or if it doesn't exist, the result doesn't exist, then it will return you null. Okay, so this is high level of near SDK, and we can now go into one.
Yeah, so basically I think we can stop. It's anyways 1 hour. But basically I think this part, what I understood, this U64 one, and I think it's a little more complex than what I understood. But the idea of this U64 is I think more like big numbers or something. So there's this concept of like, and I don't know, they are saying wrapped timestamp. So maybe the timestamp number itself could be like if it is milliseconds or something, and if it is too long to not be able to fit within the traditional U32 kind of number of bits, I think that's why they are wrapping it into a string and using this, because they are saying like earlier JavaScript did not support or something like that. That's what I understood. I'm not too sure. But if somebody has better understanding of how this kind of works, please feel free to take a shot. But yeah,
I guess Gyan, you are right. Actually, JavaScript doesn't support more than 32 bits. That's
doesn't
why yeah. That's why we have to wrap it.
yeah, that's what he's saying. So they have created their
Yeah.
own data type called U64, which is present inside near SDK. So they have created one called U128. This makes sense. This is for like 8 decimal, 16 decimal, like all the things that the number of decimals for each coin will be more, right? So they have created U128 for that. this makes sense. I was wondering why they have created U64. I mean, it's like pretty common to at least be able to accommodate 64 bits. But they are saying that just for safety or something. Because if we see the implementation of U64, it's actually taking the traditional the smaller U64, and I don't
Yeah.
know what exactly it's doing after that. But they are saying it is something like, I think, converting it into string or something. That's what he said. Like if it will return 1,000 as the string or something like that. So I guess that's what it is. And yeah, I thought exactly we have done half today, 25, 20. I didn't think we could do more than this. So yeah, I think we could do two things. One is either we just do this entire video by ourselves as homework and move on to the next one next time, or we could just do this in the next class and finish off one entire contract like while we are all together. And then from the session onwards, we could just watch these at 1.5x. So we could go
Yeah,
fast.
I guess. Yeah, I guess we can just half an hour is left. We can do it by ourselves, so that we can do like catch up the speed because I think we are running. Yeah, we have been studying since very long.
Yeah, I'm open to both options. Like if you feel we should finish one whole contract together, so at least we can cover between us, we can cover almost all the required concepts, because there will be more complex things like each of the functions we have not even started. Actually, he does not do all the functions.
Mm-hmm.
He will do mostly one or two functions. He will do entirely this vote function. So that in itself is like
Mm-hmm.
a huge one. Like it has all the things like like what assert and all these things, like how it works. And then there is like this insert, which is hash map. So how hash maps work, and then calling the functions internally. So some small things are there which, if you want, we can discuss like quickly maybe. Okay, so otherwise we could do one thing. We'll watch this video by ourselves, and in the next class
Mm-hmm.
we'll just discuss whichever we did not understand. Like here
Yeah,
are
yeah,
some things which we did not understand how they work, and we can
yeah.
discuss that part, and then we'll move on to the next one. Like we can start the next one. I will share a link to this video, yeah, over here. And yeah, okay. So I will share this in our Discord group, and I'll share it on Twitter as well. So everybody has access to this. And then in the next class, we'll just discuss this one, and maybe we'll, try to do a couple of other concepts as well. So like implementation and all, we have not done from the book itself, that concept, I think, properly. So we can try
Mm-hmm.
that. And couple of other concepts like traits and all, which are important, we have not even touched yet. So I think we should do
Yeah,
those. And then yeah, I think it will give people to time to catch up as well, 1 or 2 weeks, and we can then work on starting to write our own contracts. That will be
yeah.
significant, I think.
Yeah.
Okay, all right then.
Yeah.
So I will stop recording this one.